UCS is this awesome technology that brings together servers and storage and networking into one solution. And on the one hand, that can be a lot of fun. But on the other hand, it creates some challenges. Because some of us are networking people, some of us are storage or server folks, and we don't necessarily have background in all of these different disciplines. So, in order for us to fully understand UCS and to fully be able to manage it, we do need to dive into some of these other areas, such as storage. So, for those who don't have a storage background, we're going to cover some basic storage concepts, and then throughout the course of this skill, we're going to dive even deeper. Once upon a time, there was this need to connect a hard drive to the CPU within a computer. And even though there were a lot of different ways of doing it, eventually a standard emerged called SCSI, the Small Computer Systems Interface. And SCSI took on many forms over the years, such as IDE cables and SATA, SAS. And even though the cables changed over the years, the technology did, we continued to use SCSI commands in order for the computer to write things and read things from the hard drive. So why do we bring this up? Well, the first storage concept we want to cover is called Direct Attached Storage, which is DAS. And while there are some use cases today for DAS, for the most part, we're not relying on direct attached storage anymore for our server storage connectivity. See, DAS didn't offer much in the way of efficiency or redundancy, so we just have a couple of servers here and they're all filled with hard drives. And if this one's 30% full, but this one's like 95% full, there's no way for me to share some of his storage back and forth so that we can, be more efficient. So this is where the concept of network-based storage came into play. So rather than connecting storage into the servers, we leave the servers empty, and we put a storage array on the network. So the storage array can usually support hundreds of disks, and it's attached via the network in some fashion, and the servers access the storage as if it's directly attached. Now, this is where the DAS concepts come in, because we had SCSI, and we had physical cables to connect these servers to the hard drives, from the CPU to the hard drive on the motherboard itself. So how do we talk across a network to make sure that we get the same level of latency and bandwidth and responsiveness out of our storage that we had when the storage was right inside our box, which we don't have anymore? Well, we needed a new protocol. We still want to talk SCSI. We still want to get SCSI commands across the network. And the industry kind of created two different ways of accomplishing this. So the first would be file level storage networking, and the other would be block level. And what's the difference between these? Well, it boils down to this. File level was designed to be shared among multiple computers at once. So what this means is that no computer actually owns the hard drive. We have multiple PCs on a network talking to a storage array across file level protocols, and they all have equal access and equal rights to the storage that's on the network. Now, there are two different file level protocols we typically talk about. We talk about CIFS and NFS. Now, CIFS is a Windows-based protocol, and NFS is Linux-based. And these days, there's not a whole lot of distinction between the two. VMware environments will typically run NFS. Windows will typically run CIFS. So you pick the one that's right for your infrastructure and your environment. Next up is block. And block is a reserved protocol, we'll call it, which means that when a PC has network-based access to a storage disk, and we're using a block-level protocol to connect to it, that gives that PC full and total access to that hard drive, which means it can control the file system, it can install an operating system on that and boot from it, which we don't have that option with file-level protocols. And if another PC tries to connect to it, it's going to corrupt it, because both computers will assume that they have full access to that disk. Now, there are a couple of different protocols for this. We have iSCSI and Fibre Channel. These are the primary block-level protocols that are used in the infrastructure today. And then we also have the evolution of Fibre Channel called FCOE. And one distinction here is that file level and iSCSI, these use the typical TCP IP network, meaning I use my existing switches. That's a big advantage. Now, Fibre Channel requires its own special switches. FCOE can run on the existing network, but it does require some special switches. So even though it's Ethernet, and we'll just say that it requires Ethernet switches, we do need to make sure that the switches that we deploy in our network understand Fibre Channel over Ethernet. So in a storage networking environment, we're almost always going to be talking about one of these 5 protocols. File level is typically called network attached storage. Block level is referred to as storage area network. So between DAS, NAS, and SAN, we have a lot of different options in this environment. We have so many different options for how to do storage networking. We have file level and block level and all of the different protocols for how to support either one of those. The good news is that UCS supports all of them. I hope this has been informative for you, and I'd like to thank you for viewing.